Spectral clustering. Algorithm spectral clustering. Pseudocode steps. 1. Data preprocessing. Description: prepare the data for clustering by handling missing values, encoding categorical variables, and scaling numerical features. Steps. Handle missing values imputation. Details: replace missing values using mean, median, or interpolation methods. Encode categorical variables if necessary. One-hot encoding. Label encoding. Details: convert categorical variables into numerical format suitable for clustering algorithms. Scale numerical features: standardization or normalization. Details: standardize features to have zero mean and unit variance or normalize them to a fixed range. 2. Construct affinity matrix. Description: build the affinity matrix based on pairwise distances or similarities. Steps. Calculate pairwise similarity or distance matrix. Details. Compute distances similarities between all pairs of data points. Use Gaussian kernel, nearest neighbors, or other methods to determine similarity between points. 3. Apply spectral embedding. Description: apply spectral embedding to reduce dimensionality. Steps. Eigen decomposition or singular value decomposition (SVD). Details: compute eigenvectors corresponding to the largest eigenvalues of the affinity matrix. Project data onto eigenvectors. Details: map data points into the low-dimensional space defined by the top eigenvectors. 4. Clustering in low-dimensional space. Description: perform clustering in the reduced dimensional space. Steps. Apply traditional clustering algorithm, e.g. k-means on embedded data. Details: cluster data points in the reduced space to identify distinct groups. 5. Evaluation and validation. Description: evaluate the clustering results using various metrics and techniques. Steps. Evaluate clustering quality using metrics like silhouette score, adjusted Rand index, or Davies-Bouldin index. Details. Silhouette score measures how similar a point is to its own cluster compared to other clusters. Higher values indicate well-defined clusters. Adjusted Rand index measures the similarity between two clusterings, correcting for chance. Davies-Bouldin index measures the average similarity between clusters, with lower values indicating better clustering. Handle noise and outlier detection through cluster analysis or outlier detection methods. Details: identify and manage noise and outliers using techniques suitable for spectral clustering. Assess cluster stability and robustness. Details: monitor how clusters change over time and evaluate results across different datasets to ensure consistency. 6. Handling categorical variables. Description: process categorical variables appropriately for clustering. Steps. Encode categorical variables using suitable techniques. One-hot encoding. Label encoding. Details. One-hot encoding converts categorical variables to binary vectors. Label encoding assign a unique integer to each category. 7. Fine-tuning and optimization. Description: optimize model parameters and settings for better performance. Steps. Optimize parameters such as number of clusters k or affinity metric. Details: experiment with different values of parameters to find the optimal clustering structure. Adjust regularization techniques or similarity metrics. Details: modify regularization techniques or affinity metrics to improve clustering performance. 8. Handling uncertainty and drifts. Description: manage uncertainty and detect concept drift in the clustering process. Steps. Monitor cluster stability over time to detect concept drift. Details: use statistical tests or monitoring systems to detect changes in data distribution. Implement reclustering strategies or update clustering parameters based on drift detection. Details adjust clustering parameters or retrain the model when significant concept drift is detected. 9. Test case criteria. Description: define test cases to validate and assess clustering results. Steps: define test cases to validate clustering results against known ground truth or domain knowledge. Details: select datasets with known cluster structures and validate the clustering results. Evaluate clustering robustness across different datasets or subsets. Details: test the algorithm's performance on diverse datasets to ensure its generalizability and robustness. Evaluation metric. Description: metrics to evaluate the quality and performance of clustering. Metrics: silhouette score. Details: measures how similar a point is to its own cluster compared to other clusters. Higher values indicate better defined clusters. Adjusted RAND index. Details: measures similarity between two clusterings. Correcting for chance. Values range from -1 to 1, with 1 indicating perfect agreement. Davies-Bouldin index. Details: evaluates the average similarity between clusters. Lower values indicate better clustering quality.